Welcome to this session on 6G networking, and good afternoon, everybody. My name is Matti Latva-aho. I'm director for 6G Flagship national program in Finland. As we all know, 5G services are now being introduced, and mobile broadband services are still the mainstream in the foreseen future. But interestingly, huge promise is made through different vertical application areas, which have started to set their own system requirements to the network solutions and service quality levels and so forth. As a first attempt, network slicing has been standardized and defined to make it possible. But when there's an ever-increasing demand for a broad scale of different types of services, this really calls for new type of thinking from all different possible directions concerning 6G networking. We also probably have to think about how potentially changing future business models are changing the system architecture that is able to serve these new opportunities. For example, multi-tenancy or multi-tenant systems with a huge scale of different local customized services that are needed. Also with the various requirements for the level of security and privacy. And as we all know, artificial intelligence inspired solutions really offers a lot of potential for optimizing and managing this ever increasing complexity of the systems. One more aspect, so that the problem is not too easy, for the sake of sustainable development, energy efficiency will most likely become a really important factor as well when the overall system architecture and networking solutions are investigated and designed. So there are a huge number of different interconnected challenges and possibilities for future more efficient, more flexible network solutions. Today, we have a great pleasure to hear some of these visions and ideas from some of the leading experts working in this field. We will start this session with a presentation from infrastructure provider Ericsson. After that, service provider British Telecom, followed by a private research company, Futurewei. The session is concluded by some of the leading academic researchers in the field coming from Portugal and Finland. I would like to ask every presenter to briefly introduce yourselves in the beginning of your presentations, and audience can put questions to Q&A box in this Zoom session, and those will be handled after all presentations have been made. So now I would like to welcome the first presenter, Azimeh.
Thank you, and greeting to all of you. It is actually great to have this opportunity and to have an exchange about 6G network. My name is Azimeh Sefidcon. I am the research director heading the cloud system and platform research at Ericsson, where we focus on future computing paradigms, network-friendly cloud evolution, and network compute fabric that you will hear a little bit more today. When we define if we have the slides up, if you go to next slide, please. When we define the future, we need to take into account the driving forces, the user need of the potential technology, based on which we then identify the needed capabilities and foundation for the next generation of technologies, for example, in this case, 6G networks. We define 6G, even though still we have to admit at research phase, as a trusted platform that is delivering ever-present intelligent communication. This communication we consider to include connectivity, data, and also compute as its foundation. Taking into account the driving forces we identified, main use cases of 6G to be Internet of Senses, connected intelligent machines, digitalized and programmable physical world, as well as connected sustainable world. And we have established the main technology component of 6G to be limitless connectivity for network adaptability and extreme performance, trustworthy systems for security assurance and availability, cognitive networks for continuous learning and cognitive expectation that we have on the system. Last but not the least, network compute fabric for unified ecosystem, execution environment, unified data access, and unified application management. Next, please. But let me say a few words on driving forces and technology trends. On the hardware side, we see, of course, not only the advancement on accelerator, but also early signs of a specialized hardware such as neuromorphic and quantum processors that are designed for a special set of algorithms. On cloud side, we see continued cloudification, which even though primarily was motivated by cost and efficiency, is further enabling flexible and programmable infrastructure and platform services. Open source already has proven its value, and we see higher reliance on open source components in various implementation. Another aspect that we see as a trend is building dynamically evolvable system is going to be a norm. This is facilitated by, of course, fast evolution of underlying tools and development at a higher pace. We also see the widespread of use of AI in various layers of system, from interfaces to software and real-time interaction between the systems. Last but not the least, definitely, is internet evolution itself, which could accommodate for distributed resilience services. Next slide, please. To set the context, when we imagine the future from home to office to transportation, manufacturing, gaming, and education, all could be heavily transformed by Internet of Senses, evolution of Industry 4.0, AI to AI communication, XR, collaboration, and context-aware user data. Since these are the user reality in each specific domain, there would be a dependency on, for instance, next generation of devices with sensing and actuation. But on the fundamental technologies at the center, we would see further convergence of mobility, internet, cloud, and content, which will result in a worldwide system of interconnected components with embedded computing everywhere, which will act as one unified field, having all the capabilities for all the possible use cases across all different industries. Many of these use cases will benefit from extreme low latency, and many would have an increased focus on data. And given the size and constraint of the various devices, the compute offloading would be needed while keeping still the deterministic low latency as well. So we designed the network compute fabric as one of the fundamental components of 6G to act as a first and fast responder to event happening in the real world. Hosting computing, which is intertwined tightly with communication. And if you go to next slide, one of the aspects of network compute fabric will be to cater for unified ecosystem. The main attribute of unified ecosystem is exposure and federation across ecosystem partner based on decentralized and peer-to-peer technology enabler. This is for service exchange and service roaming. For service exchange, we would need technology that have trust embedded in them from one side and allowing decentralized ecosystem from the other side. This can provide automated sale, delivery, and charging, for example, in the case of as a service model as well. This could be done, for instance, with brokerless operation with no middleman, enabled by distributed ledger and blockchain technology. Also, dynamically building consensus-based contract could enable leasing of controlled resources like spectrum to non-operators even. Another angle of unified ecosystem is service roaming. We are used to call roaming with our phone in our hand, and in Network Compute Fabric, we foresee the same level of ease of roaming for compute services in the runtime across the globe. And the next slide, please. So just to open a little bit more, in order to successfully build an application in this context, there is a need for many different actors to partner with each other. So we have, when we talk about the 6G and global presence of that, we have to make sure that this multi-partnership is something that is embedded in the 6G. This is this could be for several reasons. For example, to normalize the cost of infrastructure, or to offer larger scale services. Of course, this scale could mean different things if you look at it from different dimensions. It also could be to allow the user to roam between providers, as we just mentioned. This partnership have two sides. Both one is the business side and another is the technical side of it. On the business side, we could think about agreements that is needed to be reached regarding the usage of resources from multiple partners who need to come together to create one service. On the technical side, this sometimes fragmented solution needs also to be integrated in the runtime in a coherent way to come to that end-to-end service that we need to offer. So if you go further, another aspect of the Network Compute Fabric is unified execution environment. We can see unified execution environment like a fluid computing that is facilitating end-to-end performance guarantees based on integrated compute service everywhere. So imagine we talked about Internet of Services. If you have sensors everywhere, to process inputs from all of these sensors, the execution environment need to be not only real time to respond fast, but also it has to be in the place that the data is happening. So it has to respond to both to network status and also actions from the environment. Then we can easily see that such execution environment needs to be portable and distributed with enabler for efficient deployment while there is heterogeneous hardware with different capabilities across the whole system. So such real-time distributed execution environment needs to adapt to the also new programming model suddenly to be also able to increase the development efficiency also. So if you look from the developer point of view. So the next slide, if you go. Just to let me break it down a little bit more, imagine if you have a scenario that with a distributed application with various tasks covering some of the typical operation of just you can consider an IoT use case that are superimposed into a heterogeneous network that basically hosted across capabilities and connectivities. So then unified runtime facilitates the execution of distributed application across this heterogeneous network. How? By placing the task where they will run most efficiently and redeploying them to take advantage of changing network conditions. So we know that the network condition change based on the users and different condition even in the surrounding environment. An application then, on the other hand, if it's running on a low power device such as a mobile phone, would like, if it likes to perform an operation that is beyond its capability, either computation wise or storage, then it will be benefiting from this distributed possibility. So to be able to answer to this offloading and this adjusting the task on the places that it should be, we in fact discard the traditional model of client-server relationship and replace it with the concept of collection of related tasks that could communicate with each other and are not tied to a specific hierarchical role or location. Then in this case, an application becomes the execution of set of tasks in order to produce a desired result controlled by straightforward business logic. The next slide, if you please. So what about the data and data infrastructure and data aspect, data access also in the network compute fabric? So we see network compute fabric should also provide seamless access to data stored in multiple locations, as if they were from a single local access to authorized user. We're talking about distributed data services while still the local policies are respected. Access to data then needs to be optimized based on the location and also based on traffic optimization and prioritization. It could be like a middleware which facilitates seamless access to data that are actually stored in multiple locations. And when we say multiple location of the data, it could be based on the use case or based on the resiliency purpose or some other perhaps regulation or even access speed and the pattern. When we talk about locality governance, on the other hand, we need to allow the players to enforce data policy close to where the data is actually stored. This is to guarantee the optimal location along data path. We believe in this area, communication service provider will have an advantage because they have this trusted environment with the subscribers. A distributed data platform also would be able to embrace the consumers who are owning the sensitive data, whether it's individual or business data. They can basically accommodate for a distributed storage space, data services, and both for the user and also for the application. Some feature of this platform also could be supervised by supervised computational storage, encrypted data store, and explicit and recoverable data access. So there is a wealth of both technology advancement there, but also opportunities. If you move to next slide, please. Network Compute Fabric also would provide flexible development and intelligent data-driven operation for managing the application. So in such a distributed dynamic environment, lifecycle management of application becomes extremely important. So these two pillars of this unification are common onboarding and DevOps evolution. And we have to realize not all application and workloads have the same level of service agreements or required inspection and traceability even, and the level of protection they need from the platform. On the other hand, with common onboarding, we mean a common onboarding for all type of applications, including telco and non-telco application, while at the same time allowing flexible co-location and even joint optimization for connectivity functionalities and also the user need. So on the DevOps side, we see the evolution toward data ops, actually, automating the analytics for the entire life cycle of data that are also related to applications. That's another aspect that is extremely important to keep in mind. So the next slide. Just to summarize and conclude, with the vision of 6G and taking into account the driving forces and use cases, we see the critical role of in entangled network compute fabric. While from an external view, network compute fabric can be bringing many unique aspects, such as allowing a broad collaboration in ecosystem and based on decentralized ecosystem and application management. From the inside, it would be a unified execution environment and unified data access and fully embedded in the network. So we believe it will bring a set of capabilities which are unique and which could also transform the network from connectivity to become an innovation platform. So thank you for that, and I will be happy to answer questions later on. Back to you.
Thank you, Azimeh. And now we have a next one coming from British Telecom. Maria, please, floor is yours.
Hi, good morning. And good afternoon, everybody. Thank you for having me here. My name is Maria Cuevas. I work in BT's Applied Research department, and I look after our what we call our mobility theme within the Converge Networks area. If you could go to the next slide, please. So I'm going to provide a bit of an operator view on perspectives on 6G. What we think the future might look like, whether or not we call that 6G, I suppose is one of the questions we would like to pose. I will recap a little bit on things that we have observed and I suppose learned from the current situation and the impact that this pandemic has had, not just in the way we live, but in the way we connect with each other. I'll talk about some of the challenges that we have as an industry and of course, again, with that operator's perspective in mind. And then moving on to, I suppose, setting what we think should be the priorities for 6G, but mainly focusing on what should we do differently this time. What are the assumptions we think we should avoid? And what are the key challenges that we need to look at, perhaps not wait until 6G is around the corner, but kind of focus on as a continuous research and development activity. And then I'll conclude with some of the summary and conclusions. If you could please go to the next slide. So slightly different perspective, I suppose, on what the future might look like. These are actually snapshots of a video that we produced at BT marketing team, looking at, I suppose, imagining what our future lives might look like. I suppose no surprise, we are all about connectivity and connecting people and connecting things. And we can start to imagine, I suppose, the new ways of communicating in the future, connecting people, connecting things, connecting, obviously, our homes and offices to make life more convenient, managing the world's resources. And of course, we're already seeing an awful lot of how technology and connectivity helps us manage our time. And increasingly, and we can definitely see a future where it's increasingly important to monitor very important things such as our health. Breaching or reducing that digital breach and divide that we are fully aware of and helping, I suppose, close the gap and changing pretty much everything we do from the way we work to the way we shop or do anything in our lives. I think one of the key messages here is that a lot of these future experiences and connected lives, we don't necessarily know exactly when they're going to happen. We don't necessarily know whether they need a new generation or a 6G to make them happen. And we need to take a holistic view about these services in terms of what is needed to make those services a reality. It will be a combination of the devices becoming available, the applications, of course, being developed, but also, I suppose, the society as a whole accepting and embracing these services, and obviously there being a real demand and a real, if you like, business case behind them. So that's just a little bit of our thinking about the future, but also how we need to take that holistic approach. Could we move to the next slide, please? Just stepping back, I suppose, from the future back to the present and our recent past and current experience, I suppose, with the pandemic. Some of the things that we have observed as an operator is obviously not just the way the pandemic has impacted our lives, but also the way that the impact is had on how people rely on connectivity. And we are having this conference, I suppose, today because there is connectivity available to all of us, and that's what's making it possible. So just to touch on a few points, we've observed, and I'm pretty sure that operators around the globe have had a very similar experience, dramatic increase in voice calls and also the length of those calls over our networks. Obviously, how fundamental internet access has been to at least two things: how remote education, making remote education possible for our children and obviously our young students, but also for us in the professional, public or private services, being able to provide continuity. BT as a business has, I suppose, undertaken one of our biggest migrations to working from home. And again, I'm sure we're not unique, making sure that our call center advisors can all work from home, and obviously all of our colleagues as well in the engineering functions. Not only that, but of course the way we, I suppose, entertain ourselves or even exercise and I suppose keep our mental and physical health have been enabled by increasing levels of connectivity during this pandemic. So that's just to give, I suppose, a bit of a perspective and a bit of a proud moment as well for how our industry has helped society survive or maintain, I suppose, connectivity throughout this pandemic. Could we move on to the next slide, please? Having said all that, we know that we have big challenges in the current and in the near term. I've kind of tried to summarize three key, I suppose, worries or challenges, as I said, as operators. The top bit on this slide shows some of the stats from our UK regulator, Ofcom. On the left-hand side, we can see easily how retail revenue, and specifically mobile retail revenue, is going down year by year. And at the same time, we can see how our data volumes are significantly increasing, and there is no sign of that trend changing in the near future. And at the same time, mobile subscriptions are remaining pretty flat. So as you can imagine, the economics is fairly obvious that the economics aren't great, okay? And therefore, we need to look for ways to obviously overcome that problem. We need to obviously provide customers what they want, which is a high, internet speeds and massive data volumes and coverage and all those good things. But we also need to make sure we are able to deliver those things at a cost-effective manner, and also, of course, try and gain more revenues to sustain our networks and our business models. The second key area mentioned here is something that probably most people in the audience are fully aware of, which is big and increasing concerns about the supply chain in our industry. The UK government in particular has taken and is taking very active action on this. There's been a paper, there is a task force that's been created and a very good paper that has just been published, providing some very specific recommendations, not just within the UK, but the entire industry and on an international level, about how we need to tackle this particular problem. We need to make sure we maintain an appropriate degree of competition, we foster innovation, and effectively grow as an industry. The third area that I wanted to mention as, again, significant challenges to overcome is, and again, just coming back for a minute to the what we've learned from the pandemic, the user behavior has changed dramatically during this pandemic, and it has, again, had a profound impact on how operators need to react and adapt to the different, situations and customer demands. So, flexibility, agility, and pace are increasingly important. But of course, we need to marry that up and make sure that we maintain the reliability. And as I said earlier, how people rely on connectivity is absolutely key. And of course, security. And we need to make sure, and there is a trade-off there. How can we do both? Being flexible, agile, and moving at a fast pace, but at the same time, providing that reliability and security that our customers need. Can we please move on to the next slide? So bearing all that in mind and having looked at the future and the present and the challenges ahead of us, we really think that we need to consider, now that we're starting to think about 6G and it's very, very early, in this journey, and it's the right time to be thinking about how we do things, not just about, I suppose, what the next performance target might be. We think, again, we need to structure the thinking at this point in time. One of our first messages to industry as a whole is that 6G has to be much more of an evolution than a generation. Okay, and we say that because, and I'll dive a little bit deeper on that on the next slide. But we really think that we need, as an industry, to be a lot more modular, where we can introduce new features and not have to replace, or introduce new technologies and refarm spectrum and all those things. We really believe that the evolution of our networks needs to be much more gradual than it has been to date, and that can only be enabled by technology, and we need to maintain that as a principle when starting to think about new generations or new technologies. As I said, very closely coupled with that evolutionary approach is, obviously, we do know that we need to continuously improve radio efficiency, and that's a must. But as I said, the how we do that is increasingly important. We need to make sure that we are extending our networks in a way that they are backward compatible. They allow for this coexistence of technologies in a very efficient way that avoids effectively, having to refarm spectrum, which, as we know, is very costly, is very complex, and is not very flexible. So how can we enable that coexistence of technologies, the seamless introduction of new features, and making sure, of course, that we introduce new features when there is a real need and a real business case behind them. Okay. Coupled with all that, by the way, we know that there is a lot of research and investment on, again, in the radio efficiency space, on new architectures. We're very supportive of new ways of building and architecting the network, and in particular the radio network, to be much more efficient and provide a better customer experience. And last but not least, talking about business case driven investment, and I think this is something that Azimeh has touched on in her presentation, is the need for an interdisciplinary approach. There is some of that already happening, but we really believe that if we are in the future generations, we need to do an awful lot more of that. We see universities starting to launch multidisciplinary programs and degrees, which combine perhaps social sciences with health sciences, as well as obviously telecoms, but also, as we mentioned before, materials, and how perhaps smart reflectors can work with antenna elements and so on. So the bringing together and the intersection between all these disciplines is what's going to bring the richness of all those future use cases that we are starting to dream of. Can we move on to the next slide, please? On the same, I suppose, vein of what should we do differently, and stopping and thinking about potentially not just assuming certain things, because that's the way things worked in the past. There are just three assumptions I would like to highlight that we believe should be avoided. The first one, we are all fully aware, I suppose, that up until now, generations have happened on 10-year cycles. And to be honest, there were very good reasons for that. We moved from analog to digital communications. We moved from voice to data-driven architectures, and all that's well and good, but it doesn't mean that we need to follow that same approach or pattern in the future. So, as I've been saying, let's stop and think. Let's make sure that we understand fully what are the drivers for the next generation. And let's also rethink our approach to investment cycles. It doesn't really mean, because we've done things as in the past, that we need to in exactly the same way again. The second assumption, again, not to be just taken as a given, is this another rule of 10 that talks about every generation being 10 times better than the previous one. And any infographic slide that we see about 5G will have at least 2 or 3 instances of 10 times better than. We really don't know, I suppose, whether that's even achievable or realistic. And we don't even think that that's the first, if you like, thing to look at. We know, and it's been discussed throughout the day, and I'm sure that we will touch on very important things like reliability, availability, security, which have nothing to do with having 10 times better speeds. We also, again, strongly believe that everything that we do in the network has to be driven by a business case and by a customer need. And we shouldn't be thinking about setting artificial, arbitrary, or even unrealistic in many cases targets for ourselves, which may or may not bring us, I suppose, what we need. Last assumption to challenge again is the trend or school of thought that says that going for higher frequencies has to be the answer. We know already from the experience with 5G that the economics of deploying technologies at a higher frequency are extremely challenging. If we even look at current millimeter wave, bands and technologies, yes, there are deployments out there, and yes, there are some use cases that they are helpful for, but they don't give us a full answer, okay? And let's not just straight away assume that that's, if you like, where the focus should be. We should be focusing on the economics and also on the models, I suppose, to allow for flexible investments and flexible sharing of different assets across the network. What else to say? Well, again, let's recap on where we are with 5G. We've obviously just started, all of us, rolling out 5G networks. We are 2 years, I suppose, into this journey. It is still in its infancy. When we look at the set of use cases that the 5G ambition or vision set out to achieve, we're nowhere near that. We are in the very early days. We are still primarily offering higher speeds and mobile broadband services to our customers. So we really think that it's too early to be labeling a particular use case 6G. We don't know whether or not those use cases are achievable using 5G technology or future evolutions of 5G technology, or perhaps whether a million other things need to happen for those use cases to be real. So we really need to question why a particular use case isn't available today, and not just assume that because it hasn't happened today, it must be called 6G. The second assumption, I suppose, we would like to challenge, or if you like, trend that we would like to avoid is just, again, jumping onto calling a particular technology 6G. We think we're at the stage right now where we welcome the research and we welcome all the industry activity in this space, but everything that's being looked at is what we would call a candidate technology. We really need to make sure that there is industry agreement that there is a valid business case for the technology before we can assume or call it 6G. Can we move on to the next slide, please? This is one before last slide. There are a number of challenges that I've not dwell on so far, but these are hugely important. And I think the key message for us is that we mustn't wait until 6G to solve these. These areas need continuous research and development. We know that we need to continue to solve the coverage issue. Indoor and rural coverage are still a challenge from, again, I've been talking about economics a lot, but for operators, those are very, very important challenges that we need to solve. So we need innovation in that space. We need to combine technologies. We need to look for new deployment models to make sure that we address that particular challenge. The second one, I'm sure we all agree, sustainability is important in anything that we do. So looking at ways to reduce the energy consumption from our networks, making them a lot more energy efficient, but also looking at use cases that help actually manage the resources that we have across the planet, and I suppose, improve, again, sustainability across the different vertical industries. Third area, which is very close to our hearts in BT as a fixed and mobile operator, and we have a number of services already in this space, is convergence of fixed and mobile. We really believe that these worlds need to come together to provide the best seamless user experience to people as they move out and about. fourth area is network automation. I know that there is a session this afternoon on network automation. One of my colleagues, Detlef Nauk, who is a world expert on AI and how to apply artificial intelligence to network automation, is going to be speaking this afternoon. I think coming back to some of the earlier comments I've made, network automation is key for us because it helps us deliver that business agility and that flexibility that I've been talking about, whilst maintaining the increasing complexity of our networks. So the capabilities we're starting to explore, like network slicing, like edge cloud compute, like orchestration of distributed resources across our networks, is introducing a level of complexity that requires this gradual journey towards network automation. And last but not least, and I've mentioned that as one of the key challenges, we need to continuously evolve the way we think about our ecosystems. And again, Azimeh from Ericsson has explained that very well, how ecosystem and partnerships is absolutely key. I would like to say that we need an awful lot more effort across industry to make that happen from all parties. We need to effectively evolve to a much more partnership approach. And if you'd like just to move on to the last slide, please, just with some of my concluding remarks. Just let's remember that the 5G journey itself has just started. We know that this technology is going to be with us for many years to come. We think it's a really good, we're at a very good point in this journey to start thinking about candidate technologies for 6G, but it is far too early to start labeling or firmly identifying use cases or even technologies. Let's do the research and the thinking first.
Thank you, Maria. I think it's time to wrap up and move to the next one. Thank you. Thank you so much for your presentation.
Thank you.
Okay, as the next one, we have Richard, and floor is yours.
Hello, everyone. I'm Richard Lee, and I work for Future Network and Futurewei Technologies. Thanks for having me here to share and discuss with you on 6G and future networks. Slides, please. Next slide, please. 5G is being deployed to support 3 types of requirements: enhanced mobile broadband, or eMBB, massive machine type communications, or MMTC, and ultra reliable and low latency communications, or URLLC. Before we set out for 6G, let's see what's going on beyond 5G. Some applications will need 2 or more requirements simultaneously. For example, high definition video upload will need both MMTC and eMBB. We call such requirements uplink-centric broadband communications, or UCBC. Similarly, when we deploy holographic type of communications or holographic teleport, we need both eMBB and URLLC. We call it real-time broadband communications, or RTBC. When we deploy high-precision positioning applications, we will need both MMTC and URLC. We call it harmonization of communications and sensing, or HCS. Next slide, please. After antenna and base stations are deployed, we need to use a network protocol to implement wireless applications. For now, we only have 2 options, IPv4 and IPv6. But are there best protocols for future wireless applications? Is there any other choice? In order to answer such questions, we need to check and verify if they meet the wireless requirements. Next slide, please. If we put all the KPI requirements together, we will see an antinomy, because there are at least 5-dimensional requirements here, and they are not always linearly proportional with each other. Instead, sometimes they are competing. For example, some applications require more bandwidth, which would likely cause packet loss for other applications. And the packet loss would make the latency longer due to retransmission. Different applications will require different KPI, and therefore they should not be treated blindly neutrally. Neutrality does not work for all wireless applications. Next slide, please. Now let's take a look at IPv4 and IPv6. A packet can be lost anywhere in the network because of congestion, checksum failure, noise, etc. In TCP/IP, after the packet is sent, a retransmission timer is triggered. The timer value is roughly equal to the round-trip time. When the transmission timer times out, the packet is considered to be lost and will be retransmitted. In this case, the latency will be tripled, 3 times bigger. Since such a design is good enough for many applications, like web browsing, but they are not good for business critical and life critical applications. Here I listed a few major limitations of IPv4 and IPv6. For example, the current design does not guarantee precise KPI. A second example, the current design assumes that one size fits all, but in reality, it does not fit all nicely. A third example is about industrial networks. There are more than 10 popular industrial protocols in use. In order to connect them to the internet, we need to support flexible length addresses. Next slide, please. Can we change IPv4 or IPv6 and make them suitable for 5G and 6G? Now let's take a look. You can imagine the packet format is a simulation of classical postal mail. A classic mail has an envelope and a letter. The envelope becomes a packet header and later becomes the user payload. But now the postal services have changed. The user can request some special services. For example, deliver this package in 24 hours. Can we follow the postal service evolution to design IP? I would say yes. Next slide, please. FedEx is a typical modern courier service. In addition to an envelope and a user payload, a FedEx package also has an actual paper about the sender's special requirement. We imagine an IP packet as a FedEx package. The packet will have a new component, which we call contract. In a contract, the user can specify some requirements for latency, throughput, and packet loss. And the network is required to honor and fulfill contracts. The contract carries the performance metrics. Next slide, please. New IP is a simulation of modern courier delivery service. There are many publications on new IP, mostly in IEEE conferences and some magazines. The KPI requirements of wireless applications can be included in a contract. For example, the latency and the packet loss ratio can be included as metadata in the contract. In the next few minutes, I will talk about a few examples. Next slide, please. Many industrial applications require guaranteed latency and low packet loss. If a control command arrives too late, it's no use. The classical automation is implemented by a pyramid. In the pyramid, the EIP sits at the top, and the field devices stand at the bottom. The field devices are controlled by programmable logic controller. Usually, the pyramid works on the manufacturing floor or perhaps in a factory. But for large manufacturing campus, the automation system is implemented by a network. The PLC controls its devices by sending commands over a network. In this example, we can see that the command latency is included in contract. Next slide, please. Now let's take a look at real-time broadband communication, which is a feature of BF5G, beyond 5G. An electrical vehicle often has more than a dozen of cameras, like 12 or 13 cameras, and sometimes even has over 30 cameras. In this case, we would need to send many different streams of video frames. When a vehicle is driven by a remote driver, all such frames are transmitted in real time, and we don't have much time to do a good compression. A basic method to support volumetric real-time video communication is to put all frames in different positions in a packet according to their importance. In this example, we put the more important frames before the less important ones. A live animal is certainly more important than anything else. Moreover, the front camera is more important than the back camera. In the internet, if the network is congested, the whole packet is dropped. But in new IP, we can implement a smarter method by using contract. We only drop the least important frames in the packet. In this example, when the network is congested, the back camera frames can be dropped. While receiver receives a packet, the packet is not exactly the same as the original one, but it is still better to receive something than nothing. The receiver can still take actions based on partial information. In new IP, we call such communication as qualitative communications. Next slide, please. We can even implement qualitative communications better. In a single frame, some information is more important than others. Using packet coding technology, a frame is coded as a few different chunks according to their relative importance. Then we multiplex all such chunks and put more important chunks before others. For example, the live animal in camera 4 is more important than all other cameras, but the frames from camera 4 can be decomposed into 3 chunks, 4-1, 4-2, and 4-3. 4-1 is more important than 4-2. We can do the same for frames 1, 2, and 3. Then we multiplex all such chunks so that the more important chunks are put before the less important ones. When a router is congested, the packet will not be dropped. Instead, only some less important chunks will be dropped. This technology is especially useful for real-time holographic type communication or holographic teleport. Next slide, please. How is new IP deployed? Basically, it will be deployed in a limited domain. There are a few cases. Case 1, new IP can be deployed in a large manufacturing facility, as I described earlier. Case 2, new IP is deployed for autonomous vehicle applications, where qualitative communication can play an important part there. Case 3, new IP is deployed to connect base stations and MEC, mobile edge computing sites. Case 4, new IP is deployed to connect base stations and core networks. Next slide, please. Here it is a short summary. New applications enabled by advanced mobile technology require new features and new functionality. such as guaranteed latency and low packet loss. The existing IPv4 and IPv6 need to be evolved to support new features and functions. New IP is exactly such an evolving technology that perfectly fits for 5G and 6G applications. Next slide, please. Thank you.
Thank you, Richard. Our next speaker is Rui.
Hello. So can you please put the slides? So thank you very much for this invitation. The session is being presented, and as usual, my name appears in Spanish, which, to make it very clear, I am not. The presentations of this session have been quite interesting, and I think some of the speakers will actually agree with what I'm going to say. And no, I have not seen their slide before. Let me start to give you a brief presentation where I'm coming from. So I know that multiple people from different places will eventually see this. So can you please pass the next slide? So I'm actually I'm a professor coming from University of Aveiro, but I'm more than that. I'm also the head of networks of a nationwide institute, nationwide in Portugal. So I think Matti selected people by, one extreme of Europe to the other extreme of Europe. So from Finland to Portugal, I don't think there is much bigger distance inside Europe than that. Next slide, please. My institution is actually a research institute. It's a mix of 6 public universities plus a polytechnical university and 2 companies, which are actually Nokia and Aalto. And it's structured, next slide, please, structured in multiple areas. As I said, networks and services, this is the area I'm coordinated. And if you push next slide, just to make it a very brief presentation, we basically address all these, which I would say it's more or less what we would expect of a reasonably large team of researchers on networking at this moment. So next slide. So let me try to bring your attention to a small issue. And I'm going to try to call your attention that first we are on what I call stage 1 requirements. If you put on slide, you will see that if you put next slide, actually something happened wrong here, but never mind. Stage 1 is where we are. So if we are talking about 6G and you do expect to have closed solutions at this moment, I would imagine that both the manufacturers and the operators in this session will already be very mad, because they are dropping a huge amount of money in a technology that we'll need to, actually, we need to export, see what it is. So what I'm going to try to tell you is that we are not really paying attention to reliability. So if you can move on, please. Let me try to very briefly depict some of the things that we talk about the future, right? Swarms of drones, virtual presence, holographic presence on conversation, virtual reality surrounding you on a physical presentation, or digital money, forget your credit cards, or these are haptic suits. So suits that you can wear and feel, and then you can, in this case, you are playing a shoot 'em up game with virtual guns, and you will actually feel the impact where you get hit. Or finally, I'm not sure if you are really able to see it, but this plane has a very nice situation, which is if you look through the windows, there is nobody inside. So everybody's bringing, the autonomous cars. Come on, the future will be autonomous planes. Now, the funny thing about this future is that all these pictures have a couple of years. These are, some of them are from Axis Toulouse, something are from a company called Musion, Digimani, Teslarati, or Flight Corporation, just to name some of them. Some of these pictures have more than 5 years. All of them correspond to realities that we are already living. So this is the future that we are saying that will happen because we are already witnessing how it can work. So what has been our reaction to all this and to the needs of a new system? So let's, please, next slide. So what we have and discussions that we have is simply, yeah, basically we need, for doing all these things, remember, we are doing them now. We need more speed. We need more coverage. We need more traffic. We need more responsive. I think that was Maria that said, yeah. And if you put next slide, what I'm saying is that we just multiply by 10. It's easy. We can multiply the bit rate, we can multiply the cell range, we can multiply the capacity. Well, sometimes we divide latency, we divide energy, and so on. Now, I'm not sure if this is the correct way to look to the future. Next slide, please. We've heard on the previous presentations that we are going to have this new beast, 6G. Communications, computing, even the human actions, the services, everything will be intertwined. Now you can get scared and say this is a nightmare, or you cannot get scared and say, that's fine, I understand what you're saying, it's great. It's basically having Apple across the whole universe around you, which basically this is model of Apple. But how is the ecosystem going to work? Because, next slide. Well, again, I don't know what happened to this again, because this is supposed to be a line from one place to the other. And now I'm really getting scared with what happened to my pictures because they were resized. And if the next one is also resized, then I will be dead. Everything has been resized. Fantastic. Can you go back, please? And I will try to explain this, what should be there. Okay, so let's start to discuss this. Are you going to kill the applications? I don't think so. Is your system going to do everything? Because from the moment we say that communications, computing, processes are going to be intertwined, stop talking about the current view of the telecom operator. You are developing, like we've heard, some sort of computational fabric. On that computational fabric, there will be applications or not. This is the first question. If there is applications, then where do you stop that computational fabric? Because if there are applications, this is the world we have today. But let's go to the network. The system does everything. We've already heard that we are going to have distributed things. We are going to have edges. So let's bring it a little more even to the terminal. So we have the fog devices, we have the edges, we have the data center, and we have the network. And even Matti raised the problem of multi-tenancy. Who owns each one of these? And if we are talking about the system is going to do it all, how are we going to break this? I'm pretty sure that British Telecom would actually like to own everything, but I'm not really sure if I don't know, Vodafone or Altis, just to say some people that I'm aware of that are involved would like that idea. So in the end, even if the network does it all, we are going to have some borders. And if we are going to have some borders, hey, this is basically what we have today. So I'm not seeing anything fundamentally different. So what can be different? And next slide, please. And this was supposed to be a very nice triangle. Pretty sure you all are aware of that 5G triangle where you have the URLC, IoT, and MBB, and this aims to be more or less similar. But I'm just saying that we don't need all of those things. We just need to define reliable networks. And the end is, how many nines are we talking about? But the point is that when I'm talking about reliability, I'm talking about trustable networks, and there are multiple dimensions of trust. I'm talking about reliability in terms of coverage, and there are multiple dimensions to this coverage aspect. I'm talking about reliability in terms of performance. And again, I'm talking about multiple dimensions of performance. Now, just to give you some ideas about the challenges, the way I see it, and I've noticed that we are slightly running over time, so I'm trying to rush. Next slide, please. Look at the numbers that we are talking. Fantastic. Let's have 0.1 millisecond latency. Right. Every time, everywhere. Let's imagine that you give me a 0.1 millisecond latency network. Fantastic 6G network. Occasionally, let's say, because the data center is busy, you have a 1 second delay. Now, I am doing an application. I'm running a system process that really needed that 0.1 millisecond latency. Please explain me what kind of application will need 0.1 millisecond of latency every time, but can survive with 1 second occasionally. I can tell you that the application guys immediately will design the system, his or her application, in order to be able to handle the 1 millisecond occasional non-coverage, non-latency, extra latency, or whatever. And from the moment that application does that, why do I need 0.1 millisecond? Well, I would say that give me reliability, tell me what's the level of reliability, and I will tell you the kind of performance parameters that I need. If you don't tell me that, then please don't expect the applications and society to work with things that they cannot trust. But let's go to the trust in terms of, confidentiality, privacy, and so on. Great thing I've heard on I think yesterday, about the great claim about open systems, flexible functions, and so on. So are you able to trust, let's say, your business to a system which is dynamically composed with open components that you really didn't control, and you cannot really place a liability to anyone? Is this the kind of society that we are selling? We are fully open, and of course, then we are fully exposed. Because I don't understand that as well. I need to have a reliable system with whatever trust parameters we are talking. Now tell me what level of reliability that you are going to give to me, and I will tell you what kind of scenarios could make sense in the future for that. Just don't tell me that it will be multi-tenant. If I don't trust the owner of the data center, I'm not going to centralize anything on data center. And you can go back along this discussion the same way. Now, coverage. Brilliant thing, right? Some very basic things. There are countries in the world where the credit cards are being replaced at this moment. But on those countries, you do get full coverage in a bar, in a cellar. Now, do we have, is that level of coverage reliability that we are talking about? Because if we are talking about that level of coverage reliability, then the credit card companies may, the traditional ones may not be useful anymore and are being replaced by, you know, the digital payments. If you don't have that kind of coverage reliability, then I cannot rely on my cell phone for being my digital wallet. And we are talking about one of the most basic actions that we can do today. So don't understand all those numbers if, next slide please, if you don't put some sort of precise requirements there. It's not enough to say 10 times better, 10 times better, reduce by 10 times. What is the overall system that we are designing? We cannot expect that our peak best performance will be the dominant thing that will change society. Nobody cares about the peak. What people want is level of service. So instead of keeping on banging on what's the peak values that we want, we should start discussing what's the system level performance that we want. Next slide, please. Now, after the presentations before me, I was wondering if I was going to say anything. I was saying, what can I say that, you know, Ericsson or BT or Futurewei, I don't know. And I said, yeah, come on, forget that. I think it's very clear that what we've been banging for the future is everything will be very dynamic, everything will be very distributed. And I can go to this everything and almost choose what technology we want. We are forgetting that we are starting to make claims that will only make sense on what was the realm of the real-time systems. So all the problems that people in real-time systems had is the kind of problems where we are positioning ourselves. And I don't think we are paying attention to that. As well, we are not paying sufficient attention to the problems of managing the computing and the computation at the same time. Because what good it is of saying that I will have 0.1 millisecond if I have processing done on the data center, which have variances on the load of, you know, hundreds of milliseconds. Why did I bother in one side when I didn't fulfill the rest of the problem? Next slide, please. Now, let me provoke you, and I suspect that some people in this panel will like this. Let's say I only have a 5G radio interface. Now, let's imagine that I go to all the reliability problems that I told you, and we are able to, with existing ideas, bring all them to the reliable levels that I'm claiming for. Now, my provocation is, how near will I be of the 6G world that we've been talking about? Next slide. Just some final words of things that I keep on hearing. Now, 6G requirements. Now, if you say human-centric, massive IoT, and AI in the same sentence, I personally will start saying that you are talking to politicians. because I hope everybody understands that one of the toughest requirements everywhere is high-speed trading. And you say, oh, that's physical networks. And I say, what? And what's the point? I mean, we've just heard Richard presenting an alternative to everything. So you don't expect high-speed trading to be important in the future? And is there anything about with humans in this process? And I don't want to talk everything else where humans are out of the loop. Okay. The same with vertical economical development or societal values. Okay, I don't really understand that. Okay. Now, if you want in this trust, I can propose technologies where privacy will be by design. That means that state surveillance will be impossible to do. Is that okay? So no terrorist tracking if the police has a mandate to verify what you are doing, or child pornography? We just designed a system that will make that impossible. So be careful again with societal values and economical development. These things are not always on the same line. Otherwise, Google will be out of the business. Google lives on not that. To continue, and very fast, personalities, vertical industry, again, the same thing. They are trade-offs. And if you go to security and privacy and the citizen, again, they are trade-offs. Our society is full of trade-offs everywhere. 6G will have to follow the society. All our requirements are not absolute. All our requirements for the 6G will need to be adjustable. Okay? And with this final sentence, if you can present last slide where I say thank you very much, and please feel free to ask questions or contact me offline if you want more on these discussions. Okay, thank you.
Thank you very much, Rui. Thank you. Before we are at the Q&A part, let's have a presentation from Tarik. We are going to be a little bit over time. I hope the audience doesn't mind it, so that we will have time also for your questions and response to those. Tarik, go ahead. Tarik, you're muted.
Oh, sorry. Once again, thank you, Matti, for having me here. Thank you, Alex, and the 6G World team for having me in this panel. As I said, I was muted, actually. There is a charm of being the last speaker. The charm is that I can link my presentation to the previous speaker's presentation, but there is also the problem of I'm a little bit ripped off time, so I don't have much time, so I have to go very quick. I don't have to introduce myself. You can see that on the slides. But today, what I want to talk about is I want to briefly speak about the current stand of 5G. I am also careful, like Maria, that I don't want to call use cases 6G use cases because we don't know what's going to be 6G yet. But definitely, we should know what is supposed to be beyond 5G use case and the requirements. And then I'll be speaking about maybe what should be the key technologies and maybe new concepts that probably would make the beyond 5G system, is it 5G plus or 6G, but it's going to be beyond 5G, how we can make it kind of innovative and somehow design it, let's say, out of the box or out of, let me use also the terminology that Maria was using, that the system would become revolutionary rather than just another generation of old systems. So let's look at what's going on with 5G nowadays. I think we have, or let's say the telco world is having challenging business models. Verticals do not want to buy. I don't think that an automotive is willing to pay an automotive company is willing to pay for the SIM card, so somebody else will be having his or her self-driving car. And of course, like over-the-top companies never wanted to pay for the services that are actually using the network. We still actually kind of stuck to the old business style. We have many, companies, they still selling these boxes rather than, let's say, softwares. Although in 5G, we have actually achieved a big step in terms of this network slicing and softwareization. But still, there is kind of linkage, to the traditional way of doing business. The major problem is actually regulations. Licenses are very expensive, but at the same time, there are problems with the legal issues of deploying, these kind of technologies that were supposed to be, the main verticals of 5G. And here I'm showing the example of V2X and UAVs. You don't see self-driving vehicles out there or UAVs because they are not safe yet. And there are lots of legal issues to be addressed before you have a wide deployment of such kind of equipment. I think Azimeh spoke very clearly about the problem, Azimeh as well as Maria, about the problem of low average revenue per user in versus the amount of data that mobile operators have to deal with. And actually, many mobile operators, if I was actually in their situation, I would be very careful in investing into 5G system that would require lots of investment, but at the same time not sure how much I can gain out of it. And that's why maybe many mobile operators, they will do 5G just because competitors also deploy 5G. And then we had actually, I would say, like one of the biggest success of 5G is that actually we made very interesting and very challenging requirements in terms of latency, in terms of bandwidth, capacity, coverage, and so on and so forth. And somehow even there were people that were saying, actually, if we achieve that 5G with all of those requirements, there will be no other generation. But the situation is that we don't have many of these requirements of 5G not really met, at least, the 1 millisecond latency, as it has been spoken by the other speakers, it has been very challenging. And it seems that we're still continuing the same, let's say, the same tradition, where we just use this kind of operations times or division, and we say, okay, we have 1 millisecond, now we look for 0.1 millisecond latency capacity, we want to have 10 times or 100 times or 1,000 times, so, and that's the system that we will call 6G. Somehow we're still continuing in the same fashion. Is that good or bad? This is something which needs to be debated. But let's look at, these are actually the 6 main use cases. Of course, like we have 3 main use cases, this machine type communication, massive machine type communication, enhanced mobile broadband services, and also URLLC. But these are like the 6, let's say, the main use cases of 5G. In my humble opinion, massive Internet of Things, broadcast-like services can be achieved with 4G, of course, with this narrowband Internet of Things addition to the system. Millimeter wave, with this combined with the LTE and also with the core network of 4G, we can achieve this enhanced mobile broadband in dense areas where you have buildings where you can put actually many millimeter wave antennas. But what has been missing or not really achieved in the context of 5G, although it was actually aimed for in 5G, is actually anything which is relevant to reliability. And I think Rui spoke very clearly about the problems of reliability and also the value of a system that can give you reliability but doesn't give you other metrics. So this is something which is left, let's say, for the beyond 5G system. And this is basically how I see the use cases of not 6G, but I would say beyond 5G. So basically, still we have some old use cases, all in the context that they have not been achieved yet. All use cases that we are inheriting from the 5G system. They're not there for many reasons, not only the technological problems, but also legal and also regulation problems. But also there are lots of interesting and very challenging use cases that are actually coming up. Some of them are this holographic communication, Internet of Everything, Internet of Intelligence, digital twinning, and so on and so forth. Now let me just share with you some of my thoughts on how at least this 6G should be, or this beyond 5G system should be. And one very important thing which I want to highlight is, in my humble opinion, there is a KPI that has been really missing in all the design of the previous systems. Of course, like as I said earlier, we always keep on repeating mobility, reliability, coverage, flexibility, and so on and so on. Yes, these are actually very important KPIs in this big cake, let's say, of this new generation of systems. But in my opinion, one missing KPI is what I call user friendliness. And it's not the user friendliness as we understand it nowadays. Of course, user in the context of 5G and beyond, it can be the end users like us, the user equipment users. It can be also vertical. It can be the network manager, the network administrator. It could be any consumer of the system. And basically, the idea is how you can make that system, whatever system that you make, how you can make it super user friendly, for whoever is using it. As end users, we have taken a very interesting journey, in this user friendliness. Of course, we started with analog. We enjoyed digital world. And we are very fortunate to be part of this touch screen generation. But actually, the next generation is actually this zero touch provisioning, where you have somebody, an entity that is actually thinking for you to take decisions on your behalf. And this is why we need artificial intelligence. When we speak about artificial intelligence, yes, there is some artificial intelligence which is being actually deployed here and there, and used by different, let's say, roles that are actually within this telco ecosystem. But they have been actually used, let's say, selfishly. For example, AI of Google is just for Google services. AI for Facebook is only for Facebook services. But there is nothing which is really cross-system AI, which is trying to have this layer of network of intelligence and coming up with a decision making which is suitable for, of course, for the service, but of course it's good for all these different roles or different players, in that communication ecosystem. And I think this is something which is very interesting, and I believe this is something which should mark, let's say, the brand of beyond 5G or 6G. And this should be applicable to different areas. Dynamic network management, of course, like my previous colleagues, they have spoken about network automation, smart homes, object recognition, autonomous cars, and so on and so forth. In my humble opinion, one of the biggest success of 5G was actually the fact that they could get together expertise from telco and cloud, experts from these two domains sitting under the same roof, and with applying some kind of principles of software engineering to form different communities of different open sources. And this is, in my opinion, one of the biggest success of 5G. In my humble opinion, 6G will be, or beyond 5G, to be, again, cautious about this terminology, 6G is the technology that should bring in these AI players into the game and have, this expertise, all merged towards making something which is really innovative, and then, impacting different aspects of our lives. So these are actually, by the way, snapshots which I have taken from the promotional video of 6G Flagship, which I invite everybody to watch it if you didn't have the chance to see it. Something which is very interesting, and it was actually addressed by Rui. What would be, let's say that you have a system which is super user-friendly and it gives you all those requirements of latency and so on. But what is its value if you cannot trust it? And that's why AI, of course, it is actually an enabler of this automatic security management, but it comes also with lots of kind of sophisticated cyber attacks, because AI can be fooled. And here I'm citing some of the research work that we have been doing in Mosaic Lab, where we investigate, the potential that AI brings, but also the complications that AI may also bring to the system. In many presentations that I have actually seen in this 6G World Symposium, people did talk about 6G as a network of networks. And my question is it a network of networks? One thing which is very interesting in the design of 5G, and I have mentioned that one of the true success of 5G was the fact that they have put together this cloud expertise, software engineering expertise together, and we achieved this network softwareization, slicing, and we've been actually adopting lots of interesting IT principles like microservice concept, integration fabric concept, network function virtualization, SDN. We have the service-based architecture being deployed, being considered in the 5G core, but still the network is actually being the center. Still the design of the system is made in a way that the network is actually the focus, and then anything else is coming, to use, the network. Still, by the way, even we have been using these SBA principles in the 5G system. Still, there are a lot. For example, the user plane is still not cloud native. I mean, still you have this kind of reference point models, and that's why in the design of Beyond system, still the architecture shall be really cloud native. That means you can just go to any kind of computing fabric, cloud systems, and it should work. It should be easy to manage and configure, and so on and so forth. In my humble opinion, the 5G core itself is not completely SBA, let's say, compliant, and that's why nowadays any 5G deployment that you see anywhere in the world, it is still not actually cloud based, because you still have the EPC. I mean, we have this no standalone option, which is being deployed all over the world. Yes, you expand the bandwidth by using millimeter wave, by using this G-node beast, but still, the core functionalities, everything is done, in the traditional way using the 4G system. And this is actually the option which is adopted by all mobile operators all over the world. Now, one thing which is being actually the fundamental thing of IT, or the fundamental thing of SBA, which is this concept of you have a service that can be producer and it can be consumer. And this is something which is not yet, to be honest, is not yet adopted fully in the design of 5G. And I hope that it can be considered in the design of the Beyond 5G system or the 6G system. And this is exactly what we have been doing with the 6G flagship. We're trying to define, or we're trying to see, the 6G system architecture from a different perspective. Now, for us, 6G system will be truly cloud native. Definitely, there are lots of things to be added there, entirely SBA based. But then we see it as a set of services that can be discoverable, and they can register somewhere and they can be discovered. And then you have a service that is actually consuming other services, but at the same time, it can provide the service to other services. And this is, the basic principles, as I said, of SBA. So the system itself is not network centric. I mean, the network itself is just a service that is being consumed. And of course, it produces service to others. And I'll explain the next slide what that means. But then we have like the 6G service, which is using the network, using the infrastructure, the cloud, using any kind of virtualized network functions to provide the service, to a different, 6G service. And this relationship is actually how we see the 6G system, which is actually, it's not network of networks, but we see it as a service of services. So to explain this with a little bit of clarity, you've got here the 6G application. As I said, focus should be the 6G service itself, and it can be any kind of application. And then we identified 6 services, main services. Networking is one of them. And then you have this user context, local information, activation, ubiquitous intelligence, and application compute. Now, to explain this with one example, let's say that you want to deploy a service somewhere. Of course, you need to understand, contextual information about the end users. Let's say even the gender or their geographical distribution. You want to understand certain information about the locality of these users. And then based on that, you can define how the network should be formed. And this network would be consisting of virtualized network functions that could be running, on cloud computing, edge cloud or centralized cloud or extreme edge cloud. And of course, if you want it to be managed with certain intelligence, then you've got this ubiquitous intelligence service that brings you, all the different AI models or AI algorithms that can help you, in supporting, the network automation. If things change and you want to change something, in the environment, then there is this service, which is actuation. And of course, like we're working on designing and of course describing this 6G system, which is service of services. And hopefully this document will be published soon on 6G Flagship website. Now, something else which is very, very important, and this is something which I would say that still 5G has probably didn't meet it yet, which is this ultra reliable low latency communication. And there we need this deterministic networking. I think Richard have spoken about the need for indicating, you know, this, for example, for service, how much latency you should be giving it, and how much bandwidth, and so on. And in my humble opinion, we've been able to achieve some kind of that with software-defined networking, where we specify even, you know, which route certain flow of packets, you know, should go. But we should go even further by specifying even which queues within which switches, you know, they have to go. And here I'm actually introducing this concept of software-defined queuing. There are some papers that we have been working on. I refer you to those papers. There is need, when we build any mobile network, it's actually built on a transport network. And the transport network has actually lots of complications, and there is need for this tighter integration with the transport network. So you can achieve, you know, this low latency communication, which comes with the deterministic latency and bandwidth requirements. The routing itself, and I think this has been probably touched upon by our colleague, the Ericsson speaker, where we speak about the locality governance, the network compute fabric, and so on. So when you do the routing, the service itself should be able to select which service function chain to go via, which queues, as per the concept of software-defined computing. And even when you have multiple choice of data centers, which even data center to go to receive the service. And here this routing should be not any kind of routing. It should adopt different IETF protocols like segment routing or dynamic casting, which is being actually discussed within IETF. And also this brings me, you know, to the concept which has been introduced by Richard, which is why not even thinking about a completely different new IP that can actually achieve, you know, these the objectives of deterministic networking. So with this, I come to the end of my talk. Just the main takeaway that yes, we still need this true cloud nativeness. There are lots of things to be done, you know, for having this ultra low latency communications. AI is a big player in the beyond 5G, but it has to be trustworthy. Network automation is something which is going to be enabled with the AI, but maybe we have to think a little bit outside the box, and maybe we have to think about the design of the system, not just a network of networks, but probably as a service of services. With this, I come to the end. Thank you very much.
Thank you, Tarik. We have a set of questions, but we have time only to take one, as I have meeting starting, actually started 7 minutes ago. There are two questions concerning IP versus non-IP protocols, suitability to mobile networks. And Richard, maybe you could comment on these two questions.
Thank you very much. So I know something about a non-IP initiative in ETSI. Actually, I was involved in the first life of NIN and group. So before NIN, it was called NGP, Next Generation Protocols. When I worked with BT architect, Andy Sutton, so we identified the header problem. So when we use the IP protocol to implement wireless applications, especially 5G and applications. So there's a big header text cell because for some applications, the payload is very small, like a control command. Let's say turn left, turn right, go forward. So the payload is usually just 1 byte. But if you use IETF technology, so the header is very long, and you included UDP, IP, and maybe MPLS, Layer 3 VPN, maybe segment routing, SRv6. So long, the header text can be as high as 95%, so too high. So later we need somewhere to like cut or reduce the header text. So that is one. And I saw someone is questioning that, saying that the NIN is working on the reduction, heterotext reduction. That's a correct way and direction to go. But how to solve it? There are two ways. One is that go away with IP, so design a totally brand new one. So that's ETSI is currently doing. It's called the NIN group there. Another way is that because the IP is still good, we should evolve IP. We build some new features and functions on top of IP. So it's called evolved IP, we call that new IP. So there is a debate inside the ETSI there. On the other hand, for wireless application, it's not just like a short user payload application, like industrial control. We also have volumetric application, like a holographic teleport or holographic teleportation and AR, VR. So those packets are really large, very volumetric. Sometimes they even go beyond the IP, like MTU, like 1500. Sometimes we have to use the jumbo frame. So if it's in a gigabyte cell, so the header text reduction is not important because user payload is very big. So the best way we think that is still like reuse the IPv4, IPv6 to build an evolutionary approach. Like what I described earlier, it's called the new IP, because new IP can solve both very small command issue and a very large volumetric packet issue there. So I'm sorry I have talked too much, so probably I have to cut here. If you guys are not happy with my comments, feel free to talk with me. I have too much and a lot to say about it, because I know the whole story about them there.
Maybe we need a separate session, another conference for this debate. Thank you, Richard, and thank you everybody for really nice and interesting presentations, completely from different perspectives concerning future 6G networking. And this is just scratching the surface, and it's really a huge area where a lot of more research is needed. So that's great news for us researchers. So thank you, everybody, and enjoy the rest of the day and conference. Thank you very much.